Hello everyone. So today I'm going to talk to you about Gradio, which is a platform for building interfaces using Python. So I was looking at different learning material for learning what Gradio is and what capabilities it gives us. But their quick start on their own website is actually pretty good, very comprehensive. So we're going to go over what they have on their own website, and I'm going to show you what different features Gradio provides to us. So, quick start. The prerequisite is Gradio requires Python 3.8 or higher, and that's all. So if your Python is version 3.8 or higher, you don't need anything. You can just import Gradio and use it. So what does Gradio do? One of the best ways to share your machine learning model, API, or data science workflow with others is to create an interactive app that allows your users or colleagues to try out the demo in their browsers. Gradio allows you to build demos and share them all in Python, and usually it is just a few lines of code. So let's get started. And here we see a Hello World project. So to get Gradio running with a simple Hello World example, follow these 3 steps. The first step is to install Gradio using pip. So either on your local machine or on Google Colab or any other environment that you work on, you can write pip install Gradio. You run the code below as a Python script or in a Jupyter notebook. What we are going to do, I'm going to show you some spaces on HuggingFace that actually use Gradio to build an interface between their users and the artificial intelligence models that are available on HuggingFace. But for now, let's go over different steps for running Gradio, and then we'll see what different features are available. So you can shorten the name Gradio. So in this line, you can say import Gradio as gr. So whenever you say gr dot something, for example here gr.interface, it means that you are trying to access the interface from the Gradio library. So we shorten the imported name to gr for better readability of code using Gradio. This is a widely adopted convention that you should follow so that anyone working with your code can easily understand it. The demo below will appear automatically within the Jupyter notebook or pop in a browser on a local host, and yes, that address if running from a script. So here we have 2 different text fields. One is called name, the other is called output. One you can write in, the other one is read-only, so I cannot select it. There are 2 different buttons here. So there's a clear button, there's a submit button. Let's see if they work. I don't think they work here, but so the clear works. Clear comes with the text box itself. So let's see what happens if you submit. So you just give your name and it tells you hello, your name, and you can see this is the code that does this for us. Pretty simple. Alright, when developing locally, if you want to run the code as a Python script, you can use the Gradio CLI to launch the application in reload mode, which will provide seamless and fast development. Learn more about reloading in auto reloading guide. So you can just say Gradio app.py and it will run your Python code. Note, you can also do Python app.py, but it won't provide the automatic reload mechanism. So that would be the difference if you do Gradio over Python. Now let's go over the interface class and what it does. You'll notice that in order to make the demo, we created a gr.interface. This interface class can wrap any Python function with a user interface. In the example above, we saw a simple text-based function, but the function could be anything from music generator to a tax calculator to the prediction function of a pre-trained machine learning model. The core interface class is initialized with 3 required parameters. So these parameters are fn, which is the function to wrap a user interface around. There are inputs, which tells you like which components to use for the input. For example, is it text, is it image, is it audio? And similar to inputs, outputs. So that says which components to use for the output. Is the output text, image, or label? This is very compatible with generative AI applications because we usually have text to something. So it's either text to text or text to image or text to audio. Gradio also has video, so we can have text to video. And so basically covers all of the inputs or all of the common inputs that we use for AI models. So we are pretty much covered for different types of files, and we can use this interface for our machine learning and generative AI applications. So let's take a closer look at these components used to provide input and output. Let's have a look at components attributes. We saw some simple textbook components in the previous examples, but what if you want to change how the UI components look or behave? Let's say you want to customize the input text field. For example, you wanted it to be larger and have a text placeholder. If you use the actual class for textbook instead of using the string shortcut, you have access to much more customizability through components. So for example, if we run this code, then let's say I'm going to enter my name here. So my name is Professor Reza. I'll submit it, and it does the same thing. It just says, hello, Professor Reza. So you can see that the text box here is not as tall as this one, because here we set the lines to 2. So this has 2 lines, but this one has only 1 line. So that's the difference. We can also have multiple inputs and output components. So suppose you had a more complex function with multiple inputs and outputs. In the example below, we define a function that takes a string, boolean, and number, and returns a string and a number. Take a look at how you pass a list of input and output components. So this is the code, and let's see how the interface looks like. So this part is our input. There is a name, so the name. Is it morning? Let's say it is morning, and the temperature maybe is 45. It is getting pretty chilly recently. So if I submit it, then good morning, Reza. It is 45 degrees today. And the number we see here is the same temperature, but in Celsius. So it's 45 degrees Fahrenheit or 7.22 degrees Celsius. You simply wrap the components in a list. Each component in the inputs list corresponds to one of the parameters of the function in order. Each component in the outputs list corresponds to one of the values returned by the function, again, in order. Okay, now let's have a look at an image example. Gradio supports many types of components, such as image, data frame, video, or label. Let's try an image-to-image function to get a feel for these. So this is the code, and this space isn't working. It's okay. We will show you an image-to-image model on HuggingFace so that you can see that. Let's not worry about it. For now, let's see what the rest of the document says. When using the image component as input, your function will receive a numpy array with the shape, height, width, and 3, which is the 3 dimensions of the image, where the last dimension represents the RGB value. We'll return an image as well in the form of a numpy array. You can also set the data type used by the components with the type equals keyword argument. For example, if you wanted your function to take a file path to an image instead of a numpy array, the input image component could be written as gr.image type equals file path, and you can set the shape. Also, note that our input image component comes with an audit button, which allows for cropping and zooming into images. Manipulating images in this way can help reveal biases or hidden flaws in a machine learning model. You can read more about the many components and how to use them in the Gradio docs. Alright, so the next one is chatbots. Gradio includes a high-level class gr.chatInterface, which is similar to gr.interface but is specifically designed for chatbot user interfaces. The gr.chatInterface class also wraps a function, but this function must have a specific signature. The function should take 2 arguments, message and then history. The arguments can be named anything, but must be in this order. So message is a string representing the user's input, and history is a list of lists representing the conversations up until that point. Each inner list consists of 2 str representing a pair, so it would be the user input and the bot response. Your function should return a single string response, which is the bot's response to the particular user input message. Other than that, gr.chatInterface has no required parameters, though several are available for customization of the UIs. So this is just an example. With just this simple code, we can create a chatbot. Obviously, there's no model connected to it, so it's not going to give us a response, but I can just write it here, press enter, and it will just give me something. It's always going to say yes. So if I write, how are you? No. Are you not okay? All right, let's. So this is just randomly creating either yes or no. So that's the random choice between yes and no. But technically, if you have a model that can generate responses to prompts, then you can use this to create a chatbot. We can clear the chat, we can undo again, we can retry something, or just clear the whole chat. There are also more complex features available in Gradio, which gives us the power to create more complicated interfaces. So one of them are the blocks. They provide more flexibility and control. Gradio offers 2 approaches to build apps. The first one is the interface and chat interface, which provide a high-level abstraction for creating demos that we've discussed so far. But there's also blocks. Blocks, they are a low-level API for designing web apps with more flexible layouts and data flows. Blocks allows you to do things like feature multiple data flows and demos, control where components appear on the page, and handle complex data flows. So for example, outputs can serve as inputs to other functions. We can also update properties or visibilities of components based on user interaction. And all of it is still in Python. So if this customizability is what you need, try blocks instead. Now let's have a look at an example of blocks. We call it hello blocks. Let's take a look at a simple example. Note how the APR here differs from interface. So this is the code, and this is how the interface looks like. So if we look at it, we created a block. So all this is in a block now. Then I have a text box, which is name. I have another text box for the output. I have the greet button, and we have a method for greet button click. So let's say my name is Reza, and if I say greet, it just says hello Reza. Things to note here. So blocks are made with a with clause, and any component created inside this clause is automatically added to the app. Components appear vertically in the app in the order they are created. So later we will cover customizing these layouts. A button was created and then a click event listener was added to this button. The API for this should look similar, like an interface. The click method takes a Python function, input components and output components. Now let's see how we can add more complexity. So here's an app to give you a taste of what's possible with blocks. So feel free to go over the code, but basically using this code, we can create a block. Now, inside this block, we have different tabs. In each tab, we have different components. So there are text boxes and buttons here. There's an accordion menu that we can close and open. And in the second app, we have two images. So one is for an input image. We can drop images here. This is for the output image. And then, so for example, let's see if it actually works. So if I have this and I click flip, so it flips the image for me. So there's a lot more going on here. We'll cover how to create complex blocks apps like this in the building with blocks section for you. Congrats! Now you're more familiar with the basics of Gradio. Go to our next guide for more about the key features. So yeah, this was a very brief tutorial of Gradio and what features it provides us. Now we can actually move to HuggingFace and look at some of the spaces that are available here. So we are in HuggingFace right now. I go to spaces and let's check out this fastest stable diffusion. Here you can see that using Gradio, you can create these complex interfaces. You can add a lot of different features here. So, and here in the tabs, we can see different features. So there's a text to image. So if you have this prompt, it will create something like that. If I generate again, it probably creates something different. So yeah, we can use this prompt and each time it will generate a new picture for us. I can try a different prompt. Let's say a village made of mushrooms. These are the positive prompts and these are negative prompts. So you don't want them, for example, you don't want it to be 3D, you don't want it to be cartoon, you don't want it to be anime, you don't want to have deformed eyes, nose, ears, or nose. Like nose is twice. So maybe we can get rid of that. It also doesn't really apply to a village of mushrooms. So yeah, let's just say I don't care about that. I just don't want it to be 3D, anime, or cartoon. So let's see what it creates. And you can see there are all these different settings that we can use the interface to let the user set. So it makes it very convenient for the developers as well as the users to interact with the model in a graphical way. And yeah, we see this image. It looks interesting. I like it. How about, I said it's red mushrooms. And I actually want it to be anime. So here I can add another keyword that I want it to be anime style. Now let's see what image it creates. Interesting. It looks interesting. Or I can just say mushroom houses. Let's see if it makes houses looking like red mushrooms. Yeah, that's pretty interesting. It does a good job. All right. We can also try the image to image feature. So you can choose different sampling methods for the image. You can do some different settings. I'm not sure what. So there are many different spaces available. Let's see, video retaking. This one isn't running. What is Wonder 3D? So apparently it turns 2D images into 3D. So if I pick this and click generate, they may take a while, but we'll see how it works. And many of these models, as you can see, they already have different examples provided here, so you can just play around with the examples that are available. Similarly, there are different settings that we can change to see how the model's generation is going to be different with different settings. Okay, so now we have the reconstructed image. I'm not sure what it did. So if I save it, it's just a PNG. Well, basically what it did was just removing the background. Did a good job at that, at least. So let's see, is it creating the 3D object down here? We can wait and find out. Okay, so it's trying its best, and we should remember, to be fair, it's only one image, and again, it's trying its best to create a 3D mesh. I mean, I would say this is pretty impressive. They're kind of getting that this is a human head. There has to be like hair, like from different angles. And I am impressed by just one image, only from a face. It's trying its best. And there are all these different images, these sample images that you can try. This model is illusion diffusion. What it does is that you can choose an example of a certain pattern, and you give it a prompt of what you want this model to build, and it can generate an image that gives you the optical illusion similar to one of these patterns. We can also upload our own pattern here, but for the purpose of this demo, let's say I'm choosing this pattern, and my prompt is maybe a mountain in a desert. And let's run it. This model tries to create an image of a mountain in a desert, which gives you this optical illusion. So yeah, here we go. It actually, it is pretty impressive. Yeah, so definitely if you make the picture smaller. So we can see that based on our prompt, it created an image of a mountain in the desert, which gives us the illusion of this pattern. So thank you for watching this demo on Gradio with me. I hope that you enjoyed it, and I'll see you in the next video.